we just plumb a specific function that does this. And so, as I said, it came for free. So like it reacts to the tags. You see, oh, it's for K-mod6. So let me see if we can, for these packages, build a .iso image that people can use at install time to enable that kernel module. And so it was working fine. Mandatory schema, because it seems really mandatory these days. So I took one that I did. Like it's really clearly coming from my mind mapping for the signing service several years ago. I like to reuse it because it's clear. So it started from Git source. So now it's git.central or GitLab. You submit a build task, either like manually or through some kind of automation that you have already. And we, as a reminder, we are using 3 tags. It was discussed a long time ago for candidate testing and release. If you build a package in candidate tag, nothing happened. It's just, I mean, you see the builds, it's there in Koji, nothing happened. You can trigger some automation just to do some testing at that point if you want, but it's just the internal. If you tag it to testing, then it triggers something that the signing service catch on the message bus and say, oh, I need to do something with it. Let me just create a consumable repository that will be pushed out. The repository metadata are signed with your GPG key, but not the package. The package are still unsigned due to an initial decision from the CentOS board just to say, well, everything that goes to testing is just not unsigned. But it goes to what we call the build log CDN. Don't blame me for the name. I'm the one behind. I found that ID initially, but I can explain why. We should rename it probably. And so it goes there so that you can use public consumption. It is backed by CDN, so clearly you can use it for your own testing. But don't point your user to that direction, to that CDN, because it's unsigned. It's really just for testing purposes only. The next step is clearly release, and then it goes really like the whole process of each package being GPG signed. The signature is uploaded back into Koji, repository is created again, and then goes to the mirror network. By the way, if you have a question, don't be afraid of asking now, because we have a dedicated Q&A section at the end, but I don't want to stand between you and the lunch, because I'm the last one in the morning, the last session, so it's really hard. So, talking about the, yes, you have a question. Go for it.
Can we have sign testing as well?
I mean, technically, it's just something we can enable, but you should probably open a ticket at the board level because it was a decision from the CentOS board initially to not sign at that level. If the CentOS board says fine, it's just a matter of changing and say, yeah, we can enable it, and then it will be done. I think that you have just one board member on your left. Feel free to chat with him during the talk.
I will help you file a ticket.
So when I mentioned build logs and .centos, the name came from when we started to build CentOS 7. You know that for a long time, CentOS was still being built on some machine somewhere, but not exposed. So people were complaining that they were not able to follow the distribution builds. So for 7, we were still using our distributed builds on infra, which is not Koji for CentOS 7, up to CentOS 7. But we wanted to at least expose the mock config file for each package, the build logs, so what is coming from the mock build, to a central place that people can just follow and eventually help if we had problem building a package for distribution, just to bootstrap CentOS Linux 7. So the name build logs came to mind. It should probably be renamed to something like testing or whatever, I don't know, open for ID, but clearly we can rename it. So it's really small infra, but thanks to a sponsor called CDN77, it's backed by them. So clearly, if you point your automation to build logs, you will retrieve the package from the CDN. So it should be still okay. Don't abuse it, because the next step should be really going to the mirror network. Mirror.centos.org exists for maybe almost 20 years now. I don't know. I don't remember, but it's really a long time ago. It was just running from sponsored machines, from sponsors all around the world. But the bad news is it will go away. It will be decommissioned completely in 2024. Why? Because that one exists for CentOS Linux 7, which goes end of life next year, and for CentOS Stream 8, which also goes end of life next year. This is the first time in the CentOS infra history that we have 2 releases going end of life at the same time, meaning that we have to reinstall everything before that to CentOS Stream 9. So mirror.centos.org will go away, and the same legacy mirror list services will go away because there is no need to keep something running for something that is end of life and will be archived completely. But if mirror.centos.org is dead, long live to mirror.stream.centos.org. So you clearly see that there was a new path starting from CentOS Stream 9. Everything with stream in the name, in the fully qualified domain name, means CentOS Stream 9 and beyond. So it's easy to remember. So mirror.stream.centos.org started from CentOS Stream 9. It has a CloudFront infra in front of it, but don't use it because Adrian, in his previous talk, mentioned Mirror Manager. So clearly, you should be using Mirror Manager. But in worst case, there is one that CloudFront, that Mirror Manager can point to, which is that one, or another one, which is in the same setup. And we still are relying on sponsors infra for rsync.stream.centos.org, which allows the third-party mirror to pull all the content from us. So everybody likes graph, so just one for you. Just some statistics I got from Zabbix for that mirror network. So sponsor, so nothing about CloudFront, just like sponsors infra. And clearly you see from the peaks when there was a Stream 9 push, a massive compose going out. And total aggregated bandwidth was something like 17 gig at the time. Just talking about the machine we control, not about the third-party mirror, which of course we have no statistics from. So, but I remember when you started, it was more or less like if we could hit 1 gigabit per second, it was really great. Now it's of course 2023, so it's better. So once you build your packages and you want the package to go out, hopefully you do some kind of testing before tagging to release. This is where CI comes to mind. So CI.centos.org, which is legacy, and the initial platform was decommissioned last year. The idea of CI was CI.centos.org was just central Jenkins where you could just do automation and interact with the infra. But it went away completely. It was replaced by something new. The idea is that we provide OpenShift for you. Here we go, sorry for the reminder. OpenShift and Duffy. So Duffy is a strange name for an API that I will explain after. It's worth knowing that you can interact with one or the other, or none, or both. It's really up to you. All the services that I'm describing are really opt-in. So it's really like a Lego or a puzzle. You can just take building blocks from all these services and do whatever you want. So initially it was hosted on premises in a data center, but it moved to the cloud. And the last step is to decommission the on-premises OpenShift cluster we have that will go away end of March. So gentle reminder, like between quotes, if you are a SIG and still using the old one, it will go away soon. I know that Hyperscale has to migrate to the new OpenShift, which is running from AWS completely. So again, thanks a lot to Amazon for sponsoring that infra because it's really there for you. So we can use or abuse it, depending on how we look at it. So on the left, it's what's still left behind from the Red Hat data center for CI, dedicated environment. And everything moved on the right, more or less. So we clearly deploy EC2 instances, ARM64 and x64 in EC2 for you. So you can just request a machine on demand. You will get it. You will run your test. You just talk to the API back, say, hey, I'm done with my test. And this is just a machine that just recycled like this and waiting for you and contextualized for you automatically through a specific API endpoint. That can or not be done through the OpenShift solution that we deployed in December in AWS, and it is using AFS as a storage solution for your persistent volume in OpenShift. And we have some kind of VPN tunnel between these VPCs and until the Red Hat data center there dedicated for CI. Why? We needed to keep something on premises. One architecture, PPC64LE. We have some SIGs relying on PPC64LE, clearly, because they want to test it. And it's not possible to test in AWS because they don't support that architecture. It's as simple as that. So just to ensure that the SIGs could still test against native PP64LE and not doing some kind of crazy emulation with QEMU or something like that, we have a very, very small Open Nebula cloud-based solution running on top of Power, which is there. And at the back, our solution is just using Ansible to provision either in the cloud, like in Amazon, or like on-premise cloud in Open Nebula. So we still provide both. So OpenShift, it's a big name and some people are afraid of it. You can sometimes, you can be afraid by OpenShift, but you can request your SIG. So if you really want to automate things and you just want to have something ready for you, we have manage OpenShift. We manage the platform as a service for you. So we manage the OpenShift. But what happens, like what happens in Vegas, stay in Vegas. What happens in your namespace remains in your namespace, but we are not responsible for it. So what we can provide you is a kind of managed template for a Jenkins instance that is automatically tied to SSO. And it will automatically have all the secrets mounted for interacting with the API for Duffy, which I will explain in the next slide. But it's not mandatory. You can deploy something else. As I said, it's tied to SSO, so FAS or ICO, which are the same. And the groups are automatically synced. So if you, as a SIG share, if you onboard someone in your SIG, it will automatically be granted access to that namespace. And if removed from the group, it will be removed from that namespace automatically after. It's used persistent volume based on AFS, so NFS under the hood from Amazon. And what it will look like is basically that kind of URL. This is the full URL for your application. And if you go to the SIG guide, you have the full URL to the console, the OpenShift console. You can interact with it from your laptop as well, because you can just have with the OC binary a token after you logged in with SSO. And so you can interact with from your laptop to do some deployment. The other service we provide is Duffy. So Duffy is just an API endpoint just to transparently let you request machine. So you can query interactively. It will return a JSON format, a list of available pools. So CentOS Stream 9, CentOS Stream 8, CentOS Linux 7, ARM64. We even started to support Fedora Rawhide because systemd, the upstream systemd project, is testing on that infra, and they wanted to have also Rawhide. So it's provisioned AC2 and, as I said, Open Nebula Cloud Images. One small remark, when I mentioned in C2, it's classical AC2, meaning that normally it doesn't support nested virtualization. So if you want to ask a machine and then deploy yourself another machine inside, virtual machine doesn't work. For that reason, we also support, but very, very, very limited amount of node, a bare metal instance, because Amazon can do bare metal instance. And we have that, but like we are really reduced capacity for that. So justify why you really need that. But if you do, like systemd, they really want to bootstrap a virtual machine on that machine. From there, you can grab the output to debug in case something goes wrong. Because if you just do that on a plain EC2, there is no way you can easily grab the console output. So this is something we can offer, but usually just use classical EC2 instance. What it does is that Duffy went open source completely. Akash participated in that project. So clearly you can have a look. But the idea is just to be really a thin layer. And at the back, it's all Ansible based. So it's just calling Ansible. And Ansible is really the engine that provisions everything for you and contextualizes the machine for you. And last but not least, documentation hosting. Who is having a look from time to time to wiki.centos.org? You shouldn't, Alexandra. So, like all wiki, the problem with the wiki is that it needs to be maintained and, of course, interact with it, etc., etc. So that's the reason why a lot of people moved away from this. This is a discussion for the documentation sake. So clearly, we need to bootstrap the discussion because clearly, wiki.centos.org is running on CentOS 7, going end of life next year. And no, we don't want to have a look at migrating from Moin, which is Python, to base to mine, which is still Python 2 based. So it needs to move to something else. But for you, if you want, it started first as the CentOS infrasig. We decided to go to something that was based on Markdown, and which is MKDoc based. We use a variant called Material for MKDocs, which is really easy to use. And because we had automation for this, we started to provide that as a service for the SIGs. And some SIGs like Kmart and Hyperscale, Automotive SIG, they are using that as well. You can just point to whatever Git repository it is, where it is, GitLab, GitHub, whatever. We can just take it, automatically rebuild the documentation for you, and it will be landing on that website. And I think that's it for now. I have a section for Q&A, and then we can have lunch. I promised to just keep it short, which I did.
You have extra time now.
Yeah. But I wanted to run because myself, I'm starting to be angry. Yeah, multiple question.
Front row first.
So all the people who have CI jump host access after Duffy, the on-premises decommissioned, would they still have access, or they need to request access?
So if for the project who had access initially, they were automatically granted access to the new one. And so the group were automatically created.
All right.
So it was automatically. So someone else did a comparison, had a look, and was trying to reach out to some people to confirm they were still they wanted to still use it. And if so, yes, they were automatically created as a fast group, and it was automatically deployed at the other side.
Oh, thank you.
So you should verify. If that's not the case, normally all the CI users are also automatically subscribed to a specific mailing list, and so should get all the notification that we are sending about, reminder, this is going away soon, so please have a look.
Regarding Image Builder, have you looked into the flexibility that it gives you? Because as far as I know, it kind of blocks you from what you're trying to achieve there, because it is very opinionated in terms of what kernel to use and which disk layout and stuff like that.
So can you repeat the question, but maybe with
sorry.
Yeah.
Sorry, maybe.
Now I can hear you.
I'm sorry for that. So you mentioned Image Builder, and as far as I know, it's kind of opinionated in a way that I'm not sure will give you the flexibility that you need in order to build your the images that you're looking for. Have you looked into it?
For what? For GitLab Runner?
Excuse me?
You said GitLab Runner?
No, I said Image Builder.
Oh, Image Builder. Okay. So there is an open ticket in the infra ticket for this. At the moment, Image Builder has one issue. Like for example, Hyperscale, they would like to do it, but clearly they would like ButterFS support, which doesn't exist at all in Image Builder. So this can be blocking already for them. The other is that the way Image Builder was designed through a Koji plugin is interesting, to say the least. So I can give you detail, but it's all on their page. But nothing is built on the Koji. The Koji builder will just talk to the image builder, but the image builder will just stop there. It will not talk back and upload back the artifact to the builder so that the builder can upload to the hub. So the image builder itself needs credential access directly straight to Koji app. So it's not going like this. It's like, well, it's not going like this. It's going like this, and image builder push back. I think it's a design problem myself, but I'm not designing image builder. And it needs absolutely Kerberos authentication for that, because it was clearly designed with something specific in mind. So they are open to work on missing feature like TLS authentication, which is what we are using for CBS. But at the moment, it's not there. So I would consider those two things a blocking factor to switch to image builder. But this is clearly something we can have a look at. I mean, we started investigating it.
Because for me, it was the API itself, not the way that they're running, but we're trying to build an AutoSD image through that, and just doesn't give us the flexibility that we need.
You're right. For automotive, clearly, you clearly need to use OS builds directly, because yes, image builder is really opinionated, meaning that plenty of things are hard-coded in the Go code about how you want to do things, which is the reason why some people prefer the old way of building an image, like Kickstart, and you clearly just do whatever you want inside. I think this is something on the roadmap they would like to do, like enhance image builder to be doing something that we were doing 15 years ago. Yes.
Okay, thanks. Just for FYI, there's a OpenShift operator to deploy image builder on OpenShift that my team wrote. So if at some point you're looking into deploying it somewhere,
Yeah,
then ping us.
let's keep in touch. Yeah.
Great, thanks.
Any other question? No, great. That means that we can have a lunch.
Thank you. All right, so we now have an hour and 7 minutes for lunch. We'll try to start promptly for our afternoon session so that we're not running through them. Just want to mention, if anybody does Fedora badges, there's these on a few of the tables out there. Just scan the QR code. You'll get a badge for attending today. So enjoy your lunch.
That's exactly the thing I took a picture of, and then like when we got the I even had this picture of this paper as a slide. Yeah. That's exactly this. And I didn't have a picture of it. I love like everything is like, and I finally saw the URL. It wasn't one of the tiniest. It was like a big slide, embarrassing mistakes. It's just like, what the hell? Yeah, I thought it was. Why the hell have you tried this? Yeah. I had the same idea. This is a really nice event. Like, I hope someone bought it and just like put something else. Next time speaking, we see people talk is like this mess up like this. I got all the It's just like a template. I don't want to use the template.
All right.
No, you were.
through the UI maybe, but. Oh, yeah, okay. I know the code, so I don't. So like, we're all over this. There's an initiative. Yeah, and you have like, somewhere and then just drop the big. Also, like, yeah, you just, and then, gone, like, not everybody does
Hello.
All right, everyone, we're going to get started again. We've got a run of talks again, and then we have another break. The other break does have a little extra padding into it, but I have a few extra backpacks I'd like to do a giveaway on and do a group photo before we do the next one. So I think we can keep on schedule, and we'll make it to the next break. So let's just go ahead and get started with Carolina. Thanks.
Hello. Would you like to try latest, newest cutting-edge OpenStack on a stable platform? Would you like later move to the stable one without wasting time for a transition? Here's an RDO. Let's take a quick look at the agenda. If you will have any time, please hold until the end of the presentation. I will make a time slot for a Q&A. Who we are, an RDO. Let's take some numbers at the beginning. Current release is RDO's 21st OpenStack major release. We are managing 330 OpenStack packages and 365 dependencies on the current releases. Also, at the end of the January, for CentOS 9 master branch, we had nearly 14,000 package builds. What does RDO may mean? Maybe there are ridiculously dedicated OpenStackers who rapidly deploy OpenStack, or maybe rebuild daily, regularly delivered OpenStack. But jokes aside, the RDO means an RPM distribution of OpenStack. In short, we are a community-supported OpenStack distribution. We are testing and deploying on CentOS Stream. The RDO can be deployed by different deployment tools like TripleO, Backstack, Puppet modules, or any other custom tool you can do for yourself or what suits you. In general, we provide two different sets of repositories for different purposes, RDO trunks and CentOS Cloud 6. Let's start from scratch, so from general concept of packaging as most basic part of a building complex system. I know that for many of you, those concepts are familiar, but I would like to keep this presentation consistent so anyone, but I won't get much into the details. What is a package then? In most general words, the simplest explanation is a way of distribute code. This is also a bundle of files needed to install software. It could be also a way to specify dependencies between software components and perform some prior setup actions. Packages are easy to install, easy to manage. By a proper tool, you can install it, version, track, verifying, and do all the other stuff you would like to do with your software. Packages are also a very initial brick for building complex systems like clouds, like OpenStack. There are many ways of creating packages out of the source code. Its usage depends on a kind of package format which is desired. There might be distro packages like RPMs, or there might be language native packages like PyPy for Python and all the other corresponding ones. For RDO project needs, we are focusing on a distro one. But inside the distro packages family, there are also many different formats like RPM, deep, tar, flatpaks, and bunch of them. And they can be run and built and managed by all the others package managers like RPM, again, Pacman, APT, DNF. Well, I think there's been no surprise when I said that in RDO project, we are using a Red Hat package manager. How the packages came into being? Packages to be built has a specific receipt, a set of instructions, how the package should be built, what dependencies does it have, what tools should be used to build the package, and finally, what the package should contain. In RPM-based world, we call these files spec files. It's a short from specification file. And all the package details are configured there. These files contain several mandatory sections, which sequence is not accidental. we use some of them to shape dependencies at packages at RDO. Of course, they are not all of them, and the specification files can be a very, very complex one, and this is just one we are mostly interact with. We have a preparation phase when we can do some actions on the source code before we start to package it. The phase of building, the phase of installation, the check ones when we run the test on the package, the files when we are specifying what will be on the user system, and two important directives which are very important for RDO, the build requires and the requires directives, which you can say what dependency will be used for building a package and then what will be used for a runtime of it. Building a one package is a matter of simple command in the right tool, but continuous delivery of the whole repositories for a rapidly developed project like OpenStack, that's a challenge. Once I showed you on the initial steps, it's time to change the perspective and take a look at the task globally. In every project, there have to be a kind of organization rules or a single source of truth, which would answer the questions like where, what, on what condition, in which version. In RDO project, this role is carried by a RDO info repository. It contains essential information about packages, dependencies, releases, maintainers, and all the others on the important fundamentals. The informations there are stored in a set of YAML files. RDO info is also used for any automation we are doing in the project. Any adding or updating packages has to be done through the change in content of the RDO info repository. Digging through the hundreds of lines in YAML files is not the most comfortable way of searching information in RDO info repository. So we have to have a very mighty tool in hands of packager, which calls RDO PKG. And it provides for us as a packagers some abilities like cloning package dizgits and setting remotes, introducing new packages, rebasing, sending changes for review, modifying specification files, and at the end, querying for RDO info metadata. Here's an example of output from RDO PKG info for our OpenStack Octavia package. What's important here is a set of URLs. We have a section build stacks, which is quite important because as you can see, here's a definition what version of the packages should be used for any particular release. Next, we have also a section for tags. This is a section where we are saying if for any branch the code should be pinned to the branch, commit hash, or anything, and also the list of maintainers. How new packages are added to the RDO project? In RDO, we are managing two types of packages, OpenStack packages and dependencies. For OpenStack packages, they are coming only from upstream OpenStack projects, like, for example, OpenStack Cinder or OpenStack Nova. They are created and built by RDO, and they are built by DeLorean, our automation tool, or by CBS, CentOS Community Build Service. The dependencies, on the contrary, comes from any upstream project. They are coming from Fedora, and they are built by CBS only. Note that we are providing two kinds of repositories, RDO Trunks and Cloud 6, as I said in the introduction. And both of them are composed from OpenStack packages and dependencies, but inside it, they are just shipped differently. No matter if OpenStack package or dependency, they have something in common, and this calls a dist-git repository. And this is where all the specification files lives. Together with a source code, they are taking a part in a process of package building. How can we add a new dependency package? The procedure I'm showing here is a very simplified model of it. If you'd like to have some more details about it, I would invite you to check our RDO documentation. So for a dependency, the package has to be present in Fedora repository. If not, the procedure of adding new Fedora package has to be proceeded. And this is basically a way how I became a Fedora packager. Then, if we have such a package available, the package has to be marked as RDO dependency in RDO info repository. We just have to say that, hey, this dependency is now our dependency, we will use it. And then we have a procedure of tagging and promoting, which I will explain later. What about new OpenStack package? On the contrary to dependencies, they don't come from external repository, but from RDO info itself. If you would like to request for a new RDO package, it's done by a review bug in Red Hat RDO product Bugzilla. And the same like for dependencies, new project has to be created in RDO info. This will trigger some necessary automated tasks like creating repository and synchronization, doing some and adding some CI checks, and all the other CI jobs which is needed. And in the end, the review with a new specification file for a new package can be sent and reviewed. Besides the dependencies and OpenStack packages, RDO also maintains Fedora OpenStack 6. Its purpose is to maintain and ship latest packages such as OpenStack clients, libraries, and dependencies in Fedora. The procedure of update is the same like for any others, with the small difference that the dist-git maintenance is done by RDO community, and then it's synchronized to Fedora. As we already knew how to add a new package, we should take care about the packages which we currently delivered. In RDO, we are trying to stick to the upstream code as close as it possible. And for OpenStack trunk procedure, we are monitoring the upstream projects. Let's take, for example, OpenStack Nova. The new commit is merged to OpenStack Nova, and this is monitored by our DeLorean automated tool. If we have such an issue detected, creating a new commit, we have a new package built by the DeLorean tool. And if the process is successful, we are creating a new repository and publishing it in our RDO trunk servers. And this repository we are publishing here, this is not only the package, this is a whole repository with this package, contains not only the new package and the latest builds of the REST packages in the same release. Speaking about RDO trunks, I have to mention the upper constraints files. In general, in OpenStack world, there is a requirements repository containing a global requirements list. In RDO, we are basing on it. And this list is basically the list of the highest upstream CI version, version of the package or library. And depending on this list allows us to constantly follow OpenStack development. Speaking of trunks, I have to mention that we have two approaches there. For one, we are respecting the upper constraints file, and these are our main builds. The output of that builds are going to the CentOS 9 master, CentOS 9Z, CentOS 9 yoga trunks, and all the others we are building for. But we also have an additional prediction workflow done only for a CentOS master when we are not respecting the upper constraints. And this approach allows us to predict the difficulties or difficulties with a package build with a future when the upper constraints file will be updated. To maintain the continuous delivery of the packages, we are monitoring the changes in upper constraints repository, and when it's changed and updated, we are creating automated gated review with a proposal, and after the approval, it's merged, and that's how we updated our upper constraints. What about updates in CloudSIG? On the contrary, we are not looking at the new commits, we are looking at the new releases there. If it's created in master, on a dedicated branch, automated review in corresponding dist-git is created. When it's merged, new package building in CBS is triggered. Of course, if it's successful and the promotion mechanism is done, we can say that we have the package updated. On the screen, you can see the example of the change triggered by a new version in a release. This was done for a Magnum dist-git done by our RDO trunk automate. You can also note the set of the jobs triggered by this change. For dependencies packages, the update was done for a long time in a manual way. So we have to go manually from for each dependency and make a manual review to update it. But recently we introduced a new tool which is automatically proposing dependency updates for a currently developed branch. So how does it work? First, we are checking if there is something to update. This is done by a nightly CI job. And as I will repeat, it's only done for a master branch. If such package is detected as available to being updated, we are getting the NVR name convention of it. NVR, name release version, is a naming convention which is quite a unique identifier of the packages. And by using this NVR name, we are going to the Fedora and looking for these packages, for this package, for the needed version of the package. If it's not there, the workflow will of course fail because, as I said, all our dependencies has to have its beginning at the Fedora. But if it's there, and if no other review is opened for that package, we are proposing a review with a new version. Here I want to do a little break for the journey and share a word about our main RDO tool, which makes the continuous deployment possible. The tool named DeLorean. Its main task is to provide repository with a new package build, but in general, DeLorean is a generic tool for tracking any upstream project. Maybe it will be used it could be used in your project. The name is reference to be able to go back in time. The repositories created by the DeLorean are not changeable, will not be overwritten in a time, and are stored in a unique commit hash name-based directory. Of course, all the builds history are limited to the storage restriction. I would like to tell you that you can back to the half a year ago build, but unfortunately it's not that great. But still you can go back for some time back in a time. Here's an example. How does it look like? If you go to the trunk rdioproject.org, you will see the list of latest results of our building. And by choosing, for example, CentOS 9 master, you will see such a list. We have provided here a build date, commit date, the commit hash, and with linking to the exact commit which triggered the change, a link for logs, and a link for repository itself. Take a look closer at the difference between a commit date and build date. I don't know if it's visible enough, but it's around 4 minutes, and it will be important in next slides. But how the repository looks like. At the top, you can see this unique name I mentioned based on the commit hash. Inside the repository, you will see a bunch of commit logs, build logs, and then they are started to going packages in the NVR name convention. Shortly about this convention, to make it clear, we have two examples here. First one is for OpenStack Nova package, and it's very easy because the version is 26.1.0 and release first. And the another example is coming from a DeLorean. It's that special because the release, as you can see here, is not that easy because the release is basing on a timestamp. We also adding a commit hash, which let us identify the commit, the source commit, and of course the extensions. When we are trying to build the source, not always everything goes well. Sometimes we are having something we called FTBFS. Failed to build from the source. The reasons are different. It can be infra issue, it can be missing dependency, it can be break dependency or anything, basically. And if we spotted such a situation, we are seeing it is in our RDO trunk, and you also can see it because it's upstream. And we are providing the guarantee review with the logs and all the information about the building. I have to mention that all the FTBFS has to be as quick as possible fixed in our RDO project, and this is a kind of our daily basis job to keep the DeLorean builds clean and clear. Here is our little help for this job. This is a report of FTBFS when we have all the data aggregated with the links, with the release, which was failing inside, the review logs, the date, and everything in a one comfortable place. Time to the variables. So in simple words, what's it our product? In RDO, we are delivering two types of repository, RDO trunks and RDO Cloud 6. These repositories are managed and delivered in different ways, and in this table you can see the comparison of them. What's important here, to not mix the idea of a single package, which can be dependency or OpenStack package, with the idea of an entire repository, which are trunks or Cloud 6. And as it goes for trunks, they are only built by DeLorean. New package in DeLorean are triggered by every new commit. They are delivered very close in time after new commit. And this is about these 4 minutes I mentioned you about, which was visible in the screen. For trunks, we are fetching the code as pulling all involved repository. We are doing a continuous delivery for a master branch. Keep in mind also that in RGO trunks, the packages are unsigned and are delivered in trunk RGO project servers. On the contrary, we have a Cloud 6. They are built only by CBS, and new package building is triggered by every new release upstream, which implies that they are delivered rather in days or hours than minutes. The source code is fetched by tarbals. New repositories are released after the OpenStack GA. All the packages in Cloud 6 are signed and are delivered in official Cloud Mirror, CentOS Mirror in Cloud 6. So going to the more details about the repositories. For a Cloud SIG repositories, we have two types of repositories there. Keep in mind that both of them are published after GA of upstream release and are published only for stable branches, which means that we have no master here. So first is Cloud SIG GA repo, and which contains only tested packages and are intended for production environments. And the second one is a Cloud SIG testing repo, contains only partially tested packages and intended for testing and development environments, but the packages there are very, very fresh and very new. For RDO trunks, they are delivered continuously. So it means that we are doing it also for a master. When a new release appears, master DeLorean builder is still following the upstream master, but there is a created new builder instance for appearing new stable branch. And inside DeLorean, we have the 3 kinds of repositories provided: the current, the consistent, and current past CI. So the current one is a repo with the latest version of every package that was successfully built. What's important about this repository? This is repo which allows the situation when one of the package failed to build from source and is in version behind the current master. So keep in mind that not all packages in this repository can be up to the latest commit. On the contrary, you have a consistent repository which has no such a issue as current, so it contains only packages with no failures, and it means that if we spotted FTBFS for this repo, it will just not be published. And the current pass CI, this is also a repository which has no failures, but is also verified by the CI jobs to ensure the stability of this repository. Let's take a look where we are in a wider perspective. We do know now where the packages came from, what are the spec files. We made a closer view on our main builder tool. We have also some idea about managing versions in RDO info. So now it's time to introduce the process of promoting packages to ready release state. As a promotion, we understand the mechanism of moving packages from one phase to another. We are defining 3 kinds of package phases: the candidate, the testing, and the release. Between each phases, there are performed various tests, including package installation on a different OpenStack deployment with this currently tested package. How does it look on the schema? So let's assume we have a new package version merged. And at this point of view, this package has a tag candidate. It's not available at this moment in any repository. But we have a CI job which monitoring what packages are in a candidate state, and automatically it proposes it to the testing one. After a set of CI jobs and approval of RDO cores, we can say now that the package is available in a testing repository, and there is a possibility to use it exactly, but it's still in testing. Then comes another nightly job from CI and monitoring what is in testing and not in release. And at this point, we have the most complex CI jobs to monitor what is happening. We have the different kind of deployments here to make the best integrational test we ever can. And the workflow you can see here, it only applies to the RDO trunks repository and to the Cloud 6, which are already released. For a non-released one, the process stops at the testing phase. This is an example of a change to promotion from a testing to release. Pay attention to the set of jobs which was performed here. Here on the screen, you can see a promotion monitoring dashboard. Not always everything goes well. It's rather a temporal infra issue, but usually not so red. But I think it looks tiny. Okay, now as you already know how promotion looks like, it's time to say a few words how new release looks like. OpenStack is having major release around every 6 months, and in RDO, we are trying to stick this upstream schedule as close as possible. And to maintain this delivery pipeline undistracted, we have to do some actions before the release. First, we have to do some fixes in RDO infrastructure. At the beginning, we have to add a new DeLorean builder, so the instance which will be designed for this coming release. Then we have to create some CI jobs for incoming release. And at the end, add this new release to all the automation bots and scripts we are having. When we are done with the infrastructure update, we are going to another task, which is quite a thoughtfulness, and it's about updating dizgits. What we have to do is go to all the dizgits we have about the packages, libraries, and everything we have, and basically verify if the dependencies is up to date. If anything new appeared, or some dependencies are deprecated, or just change the version. It's take a lot of time, and to help us, we have again our RDO PKG tool, which will help us to identify what dependencies should be updated. After having the dizgits up to date, we are moving to we have to create a new branches in all the dizgits. And after having a new branches, we have to have a builds for these branches. And at the end, we have an additional task, which is pinning a branches projects in RDO info. Not all the upstream projects we are using in RDO are creating the branches. Some of them have branches, but it doesn't suit us. So at this case, we have to take this project and pin it in RDO info to a specific tag, commit, or branch. Here we are. So we started from a basic source code, and we know how to fetch it and build it through all our automation tools, which makes the continuous delivery possible, up to releasing new repositories for trunks and Cloud 6. And even if our project is mature, we still have many works to do, still many ideas for improving our workflows. Currently, OpenStack RDO Z release is the newest maintenance, but there is coming featuring Antelope. And as you can see on the screen, it's going to be released at the end of March. And this is something we are currently working on to be prepared for the new release. What else? Some time ago, Fedora switched to a new PyProject macros as the recommended way to build Python packages. So as we strongly depend on the Fedora ASIC packages, we are planning to introduce these macros in every package. Of course, we are not going to do it manually. We have to develop some automation for that, but it's not that easy and obvious task. And this is still before us to do. And another way is new monitoring. On our daily basis work, we use multiple dashboards to make our work easier. And as you see before, this is an example of our FTBFS dashboard, example of a dashboard which helps us to identify the packages which are behind the upper constraints file, not only for master, but here for all the branches we are taking care. And at the end of the dashboard you already see for a promotion. And what we would like to do about this monitoring is to put it all in the one place. There are the plans to integrate all of this in a single Grafana dashboard hosted by a software factory, which we closely collaborate with as our infrastructure maintainers. And the problem of the monitoring we already have, that this monitoring is very diffused. It's different technologies and different places. So it's not that the greatest tool to monitor what's happening in our project. There is a work needed to be done in data migration and parsing, and then also in designing these new Grafana panels. And in the end, I would like to say a few words how RDO influenced the CentOS ecosystems. We have two issues here. It's about the testing. As the OpenStack is a very complex system, which testing requires a lot of different resources. So that's a great integration platform to test CentOS on a multiple level. As the RDO is testing and deploying CentOS on testing, it gives a lot on CentOS. It gives a lot possibility to improve the system and the ecosystem, the CentOS ecosystem. The other matter is a 6, and not only CentOS Cloud 6 is used in RDO. The RDO members participate in launching new 6. We are active maintainers of them. For example, messaging 6 or NFV 6. In the end, if you would like to join us, I'm inviting you to visit our page. We are also all available for you on a RDO RSC channel on our FTC server. And we also have our weekly meetings every Wednesday at 2 p.m. If you have any questions, I'm here for you.
Sorry, checking the
If
live
not,
stream.
if you'd like to contact me or find me, you can find me on the RDO IRC channel on OFTC, and my username is Karolinku.
Thank you for the talk. I was just maybe less of a question, but more of a comment. I was always inspired by RDO info approach, and since I moved from OpenStack to RHEL and Fedora, I always wanted Fedora or RHEL or CentOS to adopt this approach where you have all metadata about all components in one repo with YAMLs, where you can really see all the release engineer information, ownership, and everything in one place. I really wish we find a way to have similar set up in CentOS or Fedora or both. Unfortunately, don't know yet how. So thank you for a nice talk and good memories.
Thank you. It was not a question.
Are there any questions? Let me check the live stream real quick. All right, no questions in the live
Okay.
stream. So
So thank you.
yeah, thank you. So we're actually running a little ahead of schedule now, which is great. So if Christian and Alessandro are ready, then we can just move forward. Sorry, I'm scanning the back of people's heads from here. So can you help me find our? Yeah, backs of heads. Yeah. Hooray!
All right, does it work? Is it on? Test, test. 1, 2, 3. Yeah, all right. Should we wait till, or should we get started?
No, let's just go ahead and stay ahead of schedule. So yeah, go right ahead.
Yeah. I didn't.
Yeah, go ahead. We'll
All
stay
right.
ahead of schedule because something else might throw us off. So
All right. Welcome, everybody. Today, we're going to be talking about CentOS Stream CoreOS. My name is Christian. I'm a software engineer at Red Hat working on OpenShift. I'm also one of the OKD maintainers, and I'm the new CentOS Cloud SIG co-chair. And
Hello, I'm Alessandro. I'm a senior software quality engineer in the OpenShift on ARM and multi-arch compute nodes in at Red Hat. Yeah.
We're actually going to skip ahead over the agenda real quick. So OKD, if you're not aware, OKD is the community distribution of OpenShift, of Kubernetes that powers Red Hat OpenShift. It's the OpenShift code base running on top of CoreOS. CoreOS, in this case, can be either of two release streams. It can be OKD on top of Fedora CoreOS, aka FCOS, or OKD running on top of SCOS, which is the new CentOS Stream CoreOS. The special thing about OpenShift and OKD is that the lifecycle of the cluster and the operating system are tightly coupled. So we ship them together in a payload. And when we update the cluster, we also update the operating system. Big announcement really today. The OKD working group is joining forces with the CentOS Cloud SIG in order to produce CentOS Stream CoreOS together. If you're interested in learning more about OKD, check out okd.io. So let's have a look at the CoreOS ecosystem. We've had Fedora CoreOS for a while now, and it's been the base for our first OKD stream, OKD on FCOS, for a while as well. And now we have put CentOS Stream CoreOS in the middle as a midstream distribution, just ahead of RHEL CoreOS. While RHEL CoreOS is only available together with OpenShift, the Red Hat product, both FCOS and SCOS are also available as standalone operating systems. So, big announcement. We have a new distribution in the CentOS family, CentOS Stream CoreOS. As I mentioned, it's the intermediate step, the midstream between Fedora CoreOS and RHEL CoreOS. We have really cool technology that allows you to boot container images. What that means is we can reuse ubiquitous container registries to distribute our operating system. CentOS Stream CoreOS is part of the OKD SCOS stream, but it's also usable as a standalone operating system. SCOS is closer to RCOS, which is RHEL CoreOS, than FCOS, so we expect improved robustness with that. It is built entirely out in the open on Operate First, which is another super cool project run by the Office of the CTO at Red Hat. So how do we build this thing? In the first row here, you see the sources of truth for building SCOS. We have the CentOS Stream Yum repos, which obviously contain all the RPMs. Then we have the OS repository in the OpenShift org, which defines the operating system. It contains the RPM OS tree manifests that essentially list all the RPMs that we want to have in the image. And then we have the CoreOS assembler, which is the tool we use to run RPM OS tree, to run the RPM OS tree builds. CoreOS assembler is also called COSA. So if you hear COSA, it's CoreOS assembler. All of that we run in a Tecton pipeline, which is also obviously open source. It lives in the OKD CoreOS pipeline repository on the OKD project organization on GitHub. This we run on Operate First. If you want to check out Operate First and learn how to operate an OpenShift or OKD cluster, check out operate-first.cloud. Finally, out of the pipeline, we get our bootable container images, which we distribute through Quay, and also the traditional boot images in RAW and ISO formats, as well as AMIs and all these things that we then push to cloud providers' image galleries for distributing them. Both of these are then consumed by OKD. However, we want to emphasize that OKD is only one possible use case for SCOS. So while OKD uses both the container images and the the boot image in the traditional format, we only use the traditional format for initial provisioning. After that, it's all handled through containers. I'd now like to hand over to Alessandro to talk more about the underlying technologies we leverage to make this possible.
Okay, so Christian was saying before that the output of the pipeline that we run to build, test, publish the SCOS artifacts produces both a container image and the bootable images that we can ship into the cloud providers, raw ISOs, etc., etc. Both of them are consumed by OKD in the sense that, for example, during the installation time, you get you provision the virtual machine through the boot image, and then the configuration system that we have will rebase the content of the file system to be the one that we ship together with the payload, using as a transport a container image. To better understand this concept and to better understand what actually CentOS Stream CoreOS is, we want to highlight what are libOS3, RPMOS3, and the concept of CoreOS container layer. libOS3 is known to be a library that we call like the Git for the operating system. Git does versioning. We commit system to make a deployment bootable, right? We do that by hasn't happened